Hello, everyone. Welcome back to the second module for today, the signed network and weighted support. Following from the last module, where we talk about the game theoretical foundation for explaining three related network problems. Since we're talking about networks, let us go to today's lectures to introduce the notation for it. For the network, we introduce a graph. But differently from a traditional settings of the graph, here we distinguish two different kind of edges. Let's say individual I is related to the individuals J1, J2, and J3. We can have attractive edges where I mark as a plus and repulsive edges where I mark as a minus sign, for example. In addition to that, we got a weight function. What is a weight function? It is a number, it's a weight assigned to each graph. So let's say the weight is 2, 3, and 4 to each individuals. And we establish that if there's another individual J4 that is not a neighbor of I, then the weight should be 0. Naturally, by focusing on individual I, we can look at the neighborhoods and partition them into either repulsive neighbors, the links are negative, and the attractive neighbors. We call them friends, and we note it as EI plus for the friends and EI minus for the enemies. Next, let's talk about the features. So features can be, as we talk about in the first module, it's a binary features, whether it's a political choices or substance consumptions. And now that's abstracted into, let's say, just three features, F1, F2, and F3. These are the set of features. And each individuals can choose among those features. For example, individual I chooses feature F1 and F3. Individual J2 chooses features F1. I just do two examples. So you see that each individuals, we can note it as Xi. We called it a choice profile, and it is the set of features that it chooses. Naturally, it is a subset of all the features. F1, F3 is a subset of F1, F2, and F3. Since later we are going to use the integer programming approach to solve these problems, it will be useful for us to introduce binary notations. So we introduce this way. So let's say we look at individual I with respect to feature F1. These features has been chosen by individual I, so we note it as a 1. On the other hand, the feature F2 is not chosen, so we note it as a 0. This same logic can be applied to each J as well. So we can define those Xij. I'll do an example. Xj2 with respect to feature F1, it is chosen, etc., etc. Lastly, following the same convention of the game theoretical framework, we noted X minus I as the choices of all the other players than I. So all the players excluding I. In our application, it is sufficient to consider just the neighbors of I, but it wouldn't make a big difference of that. So let's look at the next part. Let me clean the screen a little bit. So now let's look at, let's clean everything again. Let's jump into the ultimate questions. How do individual I imitate or take influence from their neighborhood. How does the influence of the network affect individual I? So let's go with again. We've got individual I for say, um, yeah, I'm doing it again. J2 and J3, they are different individuals. Let's say this is a positive, negative, negative, friends, enemies, and enemies with influence 2, 3, and 4. For that, let us focus on the feature. So let us focus on the feature F1 for now. Okay, so that's denoted whether individual I chooses feature F1. We can note it as individual I F1, whether it is 0 or not. Individual J1 F1, whether it is 0 or not. So we make it 1. Let's make it 1 and 0, for example. Now, how do we consider to aggregate the influence? We first look at the friends. So first, let's look at friends. It is Ji. Okay. And we see that Ji is a friend that votes 1. So we will consider this as a match. This is a match. Okay. This is a match. The weight is considered. Next, let's look at the enemies. These are the set of enemies. You have an enemy that votes 1. So we consider this as a mismatch because we want to be different than our enemies. So in this case, an enemy vote 1 does not contribute to the weighted sum. Here, it doesn't contribute anything. If we look at J3, enemy is it's choosing 0, so it is a match. And the weighted support is simply this. The sum of these two terms, it will be 6 for the case. Let's look at the formula. The formula is just explaining this process. So first, let's look at all the friends. We will see if the friends has a choice that is 1 here, then this term will be 1 weighted by the corresponding edges. If, let's say, individual I got a friend that votes 0, then it will not contribute to anything. So the first term is the support from friends who adopted the feature, who only choose 1 in the feature. Let's look at the second term. Here we're summing over the enemies. But notice that instead of x, it is 1 minus x. It means that this term will contribute only if the x is 0 in this case. If x is 1, this term is 0. It doesn't contribute to anything. If xjf is 0, like in this case, J3, then it contributes the weighted support. So what are we doing now? We are calculating support from enemies who rejected, who chooses 0 with respect to the feature. In sum, we consider 2 different types of support from friends who vote 1, who chooses 1 with respect to that features, or from enemies who chooses 0 with respect to that feature. If we sum up the 2 support together, we got the total, or just the weighted support for individual I and for the feature F1. So that's why we say weighted support of IF. And before going to the next slide, let's come to the questions. How do we decide the influence? So individual I will choose another thing called threshold. Tau I is the threshold. And we will calculate 2 things. Let's compare the weighted support of the individual I of that feature F1. And if the weighted support is greater than the threshold of individual I, then what we'll do is we consider this as so the influence is greater than the threshold. It votes 1 in this case. And on the other hand, if the weighted support is smaller than the threshold, then it will vote 0. So the vote of individual I is defined this way with respect to that feature, which we're going to see in the next slide. Here, we consider a vote if the weighted support is greater than the threshold, and we consider this as not a vote if a vote 0 if the weighted support is not greater than the threshold level tau I. We can say tau is the threshold of adoption, or a quantification of the social pressure. The social pressure is like the weighted support, and tau I is your satisfactory level, your vulnerability, or your sensitivity. This is the word, your sensitivity to social support. If it has a tau that is small, then you are easily influenced by the neighbors or the enemies. In conclusion, today we talk about the sign graph neighborhoods. We got the attractive, repulsive neighbors, the partitioning of neighbors. We defined the very important concept of the weighted support as a sum of aligning with the friends or differentiating with the enemies, and we sum them up together. We also introduced the voting rule as the comparison of the weighted support with the threshold level proper to each individuals. In the next lectures, we're going to talk about endogenous aspiration. Why is tau I a endogenous variable in our model? As well as we're going to talk about the utility, individual and total utility of the voting game. Thanks for watching and see you guys in the next lecture. Bye bye.